special LVCOM series of video lecture Engineering Graphics for the projections of point. My name is Arpan Pandit. I am from Atmiya college. In the past lectures we have seen how we can have the projections of point. In this portion we will proceed further and we will look after how we can project the projections of the line. Basically there are projections of points, lines, plane, solid, then projections of intersection planes. But in this part we will see how we can project a line. Let's have a look at the first problem. If we see what are the projections of a straight line, information regarding a line means that its length, position of its with the HP and VP. In the past lectures we have seen that what is HP and what is VP. HP means that horizontal plane and VP means vertical plane. Its inclinations with the HP and VP will be given. Inclination with horizontal plane and vertical plane would be given in the problem. First one, basic simple cases of the line. How we can track the projections of straight line. We will consider very basic and very simple cases for the first time. The first problem is a vertical line which is perpendicular to HP but parallel to VP. Another one would be line parallel to both HP and VP. Third problem can be a line inclined to horizontal plane and parallel to vertical plane. Fourth one is a line inclined to vertical plane and parallel to horizontal plane. These are the basic problems which we can consider while we are projecting any sort of line. Now if we see the projections of line, basically the angle with the horizontal plane and the vertical plane is very much important, as well as there is a true length given for all the projections. How long a line we want to draw, it called as true length. Now the fifth one would be a line inclined to both HP and VP. Please consider that HP and VP means that horizontal plane and the vertical plane. Now we will see step by step procedure how we can have a better look at the cases of the line. The first case would be a vertical line which is perpendicular to HP but parallel to VP. In the next part we will see the basic illustration of the front view and the top view of the line listed above. First one is a line perpendicular to HP but parallel to VP. Means a line is perpendicular to HP, which means that it is a vertical line but it is parallel to VP. It is not on the vertical plane. How we can have a pictorial presentation of this kind of projections of a line? Let's consider this as our vertical plane. We are having two planes, right? One is horizontal plane, another one is vertical plane. Now what we are trying to do, we are trying to project a line which is perpendicular to horizontal plane but parallel to vertical plane. We are having our vertical plane over here. This is our horizontal plane. Now we will see how our line is dedicated and allocated to these two planes. We are having our XY line over here where both these projections intersect. XY line we can have. Now the red line shows that this is the basic indication of any of the line. This line, you can see that the red line is perpendicular to HP. This is our horizontal plane. It is exactly at 90 degree to the horizontal plane, but it is not on vertical plane, but it is parallel to vertical plane. As you can see that horizontal plane and vertical plane are coincide with each other at 90 degree. Same is the case over here. At some point on the horizontal plane, we are having a line which is perpendicular to horizontal plane, but not on the vertical plane. It is parallel to the vertical plane. The line is called as AB. We are having a line AB over here. This is our observer view. From this side, we are seeing the object. We are seeing the line from this angle. And this is for the front view. As you all know that front view means that from which side we are viewing the perspective of any sort of plane. We are just tracing the projections on the vertical plane. Now as you can see over here, we have just traced the projection of this red line AB on the our blue vertical plane. As you can see over here that two dots have been described, that these are the projections of AB line. We have marked the line with each other. It looks like a shadow to a line. It is the front view. How this line will look from the top view now? Front view component will always come in the A dash and B dash direction, as already discussed in the projections of point lecture, that for every type of denomination have been properly guided. Now if we are talking about the front views, the lettering should be like A dash, B dash, C dash and D dash. If we are talking about the top view, then the denomination and the nomenclature should be simple A, simple B, simple C. Or if you are using the digits, then it should be 1, 2, 3 for top view and 1 dash, 2 dash, 3 dash for the front view. If we are looking for the side view, then we will add double dash. If we are talking about the numbers, then it would be 1 double dash, either 2 double dash or 3 double dash. If we are talking about any sort of alphabet, then for the side view it can be A double dash, B double dash, C double dash, etc. Now we have seen the how we can track the projections of a line from the front view, which is perpendicular to HP but parallel to vertical plane. We have seen how the front view is looking. Now we will see how we can have a top view. We are seeing it from this top side. We are seeing it from the top side. For the top view, like this. We have just projected our top view point on horizontal plane. If we are looking for the front view, then front view will be captured on vertical plane. If we are looking for the top view would be captured in the horizontal plane. We have taken the projection like this. We have marked a dot on this projection like this, naming it as AB, as this would be in the single line itself. As I told you earlier, for the top view component, the nomenclature would be simple A and simple B. So I have written small ab over here. This would be top view of any projections of a line. Now we will just extend the front view line to the XY line and till the top view line. What is the problem? If we are talking about the top view, we cannot have the projections from the top side. Then now what we'll do? we have just projected the portions like this. Another problem is a line is parallel to HP and parallel to VP. We are talking about a line which is parallel to HP and parallel to VP. How this line can be traced in between horizontal plane and vertical plane, we'll see. This is our vertical plane and horizontal plane. This is our XY line. We have taken our line which is parallel to HP and parallel to the vertical plane. Now what we are going to do, we are looking for our front view. Front view would be traced like this. The front view would be traced like this on the vertical plane, and the vertical plane will have this line like this. This is our front view. We have marked it as A dash B dash. Now we are looking for the top view. We will just have projection on the horizontal plane like this. We will mark this point likewise A and B. So this is how we can represent a line which is parallel to HP and parallel to VP. Like this, we have clearly stated the projections of a line. Now we are looking for the orthographic pattern of these two problems. How this we have seen a pictorial presentation, but we will see how it is look like in orthographic pattern. As you can see over here, what we have done, we have just folded a horizontal plane and vertical plane component, and we have just straightened it up. If we have just straightened it up, then our vertical plane should be like this. Vertical plane would be looking like this portion. As you are seeing over here, blue component is showing the vertical plane and yellow component is showing as horizontal plane. These two are at 90 degree, but in the orthographic projection we have just straightening up. As you can see over here, A dash and B dash you can see. The same thing you can see over here, A dash and B dash. Now we have taken a dotted line for this top view projection, that is AB. So what we have done, we have just extended this line till AB and we have got our top view component. So this is how we can represent in the orthographic pattern. Front view is a vertical line showing true length and top view is a point. Now if you see that this line is dark and this is true length, which means that if we are measuring this length AB and with the capital AB, then its length would be equal, which means that it is the true length of any line. Now if we are talking about the true length, which means that it is its actual length. In the problems you might be given that the true length of a given line is 100 mm, which means that at every point of time in the front view the line would be true length. And in the top view we can just see a point, because when we are seeing it from the top we cannot see the proper projections. As you can see over here, in the orthographic pattern of a line parallel to HP and parallel to VP, you can clearly see this is our vertical plane, this is our horizontal plane. We have just straightening up. Now this front view A dash and B dash, as you can see over here, this front view is located like this. Now this is our xy line. As you can see, the xy line over here like this also. Now we have measured this distance. Let's say suppose it is 25 mm. Then the 25 mm distance to be dropped out like this. Now we have got the distance from the vertical plane, let's say 30 mm. So from the xy line, the top view angle would be 30 mm far away from the xy line. In this, both we can see proper line, whereas in the top view of this line perpendicular to HP and parallel to VP problem, we cannot see a full line in the top view, but in this, in top view also we can see the full line. Front view and top view both are parallel to XY line, which means that both shows the true length. If you take this projection like this, then both the length achieved would be true length. Either A dash B dash is equal to small ab equal to capital AB. All lines would be equal with each other, and that will be true length for the both views. Third one is a line inclined to horizontal plane and parallel to VP. Now we are talking about a line which is inclined to HP, which means that it is having some sort of inclination with HP, but it is not on the vertical plane, it is parallel line to the vertical plane. Now we will see the pictorial presentation of the same. We already know that these are our vertical plane and horizontal plane, and also we are having XY line over here like this. Now we are having a line inclined to HP like this. At some angle a line is resting on HP, but it is not on the vertical plane. It is not lying on the vertical plane, but it is inclined to HP at some sort of angle. Now what if we